Hello viewers, I'd like to welcome you to today's short video demonstration on one of our products which we call Electrokristron Inverter Battery Interface Module, EIBIM for short. EIBIM is a product that a lot of people have been asking us to shoot a video for, and today you'll be seeing that video. Thank you. Now this is a product called Electrokristron Inverter Battery Interface Module. As you can see, EIBIM. The EIBIM helps us to condition our automatic transfer switch, such as the ones we have here, which are able to automatically start the generator when power fails, when mains power fails. So the EIBIM helps us condition them to be sure that they don't start the gen when the mains power fails. What that means is, for anybody who is using an ATS and the mains power fails, if you have inverters installed, the ATS does not allow your inverter to run, because immediately power fails, the system, which is the ATS, starts the gen automatically. Now on this unit we have some terminals which are meant to control the generator. Okay, now the terminal here on the left is the one that's meant to control the generator. So if you have the gen control wires attached on that terminal, the ATS is able to control your generator for both auto start and auto stop operations. Now on the other side, you can see I have another set of terminals here, 2 of them that have been looped together. It's designed to communicate with the gen run or gen control terminal, such that when power fails, the ATS is not able to reach the generator in order to start the gen, unless a device that is attached here makes that possible. And that is why we have the inverter interface module here, Electrokristron Inverter Battery Interface Module. Okay, it serves as a go-between, between the ATS and the generator. To further understand what I'm talking about, I have a sketch here, a block diagram really, of how everything works together. Now this part represents your mains supply coming into the automatic changeover. Now you also have the generator here, running into the automatic changeover. And then the automatic changeover, like this type we have here, is able to, it has control on the gen. It is able to start or stop your generator. So with the aid of the terminals I just showed you, the automatic changeover is able to send a start signal to your generator anytime power fails. The signal for starting or stopping the gen comes from the internal circuitry of the automatic transfer switch or automatic changeover. So now in this kind of arrangement or setup, immediately power fails because of the fact that your changeover is able to automatically start or stop your generator. Now if you have the setting on auto start, it means that immediately power fails, your ATS will send a start signal to the generator and then the gen will start automatically immediately. Now the problem with that is the functioning of the ATS as an auto start system, starting your gen anytime power fails, means there won't be room for your inverter to run its course as a backup power supply, okay, which is not a good thing. It means you'll be burning diesel all the time, even when you have a backup supply system or backup facility. So because of that, we now come up with an interface between the ATS or automatic changeover and your generator, and of course your inverter batteries. This is a system that's able to communicate with all the parties involved, both the ATS, the generator and the inverter batteries. Now this is what it does. When mains power fails, your ATS or automatic changeover is ready to start the generator, so it sends a signal for the gen to start, but this EIBIM, this device here, intercepts that signal and doesn't allow it to pass through because it is busy monitoring your inverter batteries. Now as it is monitoring the inverter batteries, it is checking to see whether they are in good enough condition for them to continue running the inverter or they need to be recharged. Now based on the settings of the EIBIM, there's something we call threshold setting. We can actually adjust this to determine at what level we want the inverter batteries to the gen to start based on the inverter battery condition. Now as you're turning the variable here, you will actually see the voltage, the corresponding voltage setting. You can turn this to actual voltage to monitor the battery itself, to monitor the inverter battery itself, or you turn to preset to be able to see what values you are setting. In a short moment I'm going to show you all of that. Okay, so back to this drawing, the EIBIM ensures that for as long as the battery conditions are okay in terms of the voltage level, the gen start signal doesn't get to the generator. But the moment the battery's level drops to or below the threshold setting that you have preset, that's why we call it preset, you adjust it first, set it in place, and then you wait for the automation to take its charge. Okay, so now once you have gotten the batteries drained up to the point where they are now at par, or a little bit below, they are beginning to drop below the threshold level, then the EIBIM allows the signal to pass through. The signal from the ATS to start the gen now passes through, and then the gen starts automatically. Now while the gen is running, there is a timer here that will check to see how long the gen runs. Okay, and you can see there are buttons, there are digits here that you can actually program to determine how long you want your gen to run. If you have maybe from your observation, if you've seen that your batteries get charged fully enough within a certain amount of time, just program that amount of time in there, and then of course your batteries will charge up to that level and the gen will stop by itself automatically, based on the action of the EIBIM. So the whole of this is what I can call a perfect scenario for somebody or anyone who has an automatic changeover along with an inverter, because with this in place, with the EIBIM in place, you'll be confident that anytime your inverter battery level I'm talking about the voltage now. Anytime the inverter battery voltage level drops to a certain threshold setting, you are sure your gen will kick in automatically. Okay, and that is not to say that if your gen was running already and NEPA or mains comes back, of course the ATS is there, the automatic changeover is there to do its automation thing and automatically shut down the generator irrespective of whatever level of charge the battery has attained, because once it changes over to mains, the batteries will continue to charge from that point on. Okay, now if it is charging, that is while still charging, if power fails, then the process just kicks in again, as in the EIBIM monitoring process kicks in, and then if the batteries have not charged up to a point where they can serve you, the gen will start automatically. All right, so without much ado, let us go into the demonstration proper. To proceed with the demonstration, I'm going to ask my assistant, engineer Tunji, to open up the EIBIM so that we can see the terminals we're connecting to inside. TJ. Okay, here we are. You actually have two boards inside the unit. Okay, one here is the power board, and then you have the control board over there. Now here I have a connector which is labeled as power. Okay, that's the power connector. That's the one that supplies power to the transformer there, which is the one that runs the system. It powers the board, and then the board distributes around the entire system. So basically, for the system to come alive, this must be connected to a 220 volt or 230 volt AC power supply. Now the power supply is actually taken from the inverter supply itself. Okay, that's the power terminal indicated there, being fed by the inverter output itself, the 220 volt output, which is the same output that powers your light duty loads in the apartment or building. It's the same line that powers the EIBIM supply as well. Okay, for the EIBIM to work, it must have power, and the power is 220 volt or 230 volt AC. Okay, now there's also a terminal here which is labeled 12 volt battery. Okay, 12 volt bat or 12 volt battery. Now from this drawing, you can see I have two links there, two lines going out to the battery, the negative, okay, negative and positive lines, or terminals. So basically these two, black, you can see the colors are black and red. They are to be connected to one of your batteries. It doesn't matter if you have 6 batteries, 10 batteries, 12 batteries, no matter the number of batteries you have in your inverter battery bank, that terminal has to be connected to monitor only one of those batteries, only one. Okay, you can just choose a random battery. It could be this, it could be that, it could be any other one, but it has to be a single battery. Okay, in case you have a battery bank of 6 volts each, okay, this is 12 volts, 12 volts. Some people have batteries that are 6 volts each, or maybe even 2 volts, or something like that. But whichever way, the idea is that you're either using 6 volts or 12 volts. So if you have a 6 volt battery bank, you can choose from one of the 6 volt batteries and connect. The system will still work. But if you don't have 6 volts and you have 12 volts, 12 volts is okay. For the most part, most people use 12 volts anyway. Okay, so now we understand what this is meant for. 12 volt power, DC power from your battery. But we actually call this sensor line because the purpose of this line is just to monitor your inverter batteries. It doesn't really consume or take power from the battery. It's just there to monitor the battery level. Now this other one here is labeled Gen Start. Okay, Gen Start. Now the purpose of this Gen Start is to link up with your automatic changeover, okay, like the one we have here. Now when it links up to that terminal there, it's able to adequately communicate with the ATS. Okay, so you just bring those two wires here, remove this loop. This loop is there to just act as a temporary bypass for the EIBIM. But if you're going to use the EIBIM, you have to remove this loop and then connect these two terminals to the one you have here, and then of course the system is set up properly to run. Now I have indicators on the boards. Okay, the indicator here indicates the moment you connect power, the moment you connect this to the inverter battery, the inverter supply, power comes up and then the indicator is alive. Likewise on the front of the system, okay, both the one on the panel and the one on the fascia comes up simultaneously. Now you also have another one here. This red one here is linked to the back link. The moment you connect your batteries for monitoring, both of them come up. Okay, the inner ones are good for when you are setting up, so as you are doing your connections you see them come alive immediately. Okay, but once the system is covered up, you can still monitor everything from the indicators on the front. Okay, now the third one, which is this green one, is the one we call trigger. Trigger means that point when your preset level, the preset threshold level and the actual, both the preset voltage and the actual, the point at which they both meet and the system comes alive in terms of starting your generator. Okay, so we're going to see how all of that works in a short while. So we just take this off and then we do our connection. TJ, please bring the other one we have connected already. Okay, now it's the same unit and this one has all the wires already attached. Okay, the wires are attached already. Okay, here is an indication device for Gen run signal. So we know that Gen run signal has been sent to the ATS when this comes on. Okay, now you saw 3 terminals in there and these are 3 cables. One of them is for power, this one is for power. Okay, this one is for power. Okay, this will go to the inverter output supply. We're using this inverter. Okay, and we'll be connecting our EIBIM plug straight to that socket there on the inverter. Now we'll be using this small battery, this small 12-volt battery for our test purpose. This is an indication device for us to see when the power is, or rather the signal is sent from the EIBIM to the ATS. Okay, so here we have 2 crocodile clips all the way from, coming from the EIBIM. The red is representing positive connection to the battery positive terminal, and then the black one for the negative battery terminal. So at this point we are all set to begin our connections. TJ, can you help me with the connections, please? Negative to negative, positive to positive. Okay, good. The inverter has come alive and our EIBIM has also come alive. Now, when you put the EIBIM on for the first time, because you have not set the threshold, okay, the EIBIM may be in self-test mode, where you find almost all the lights coming on. Okay, don't be alarmed, it's okay. Okay, that's the timer. Okay, we have actually set to 10 seconds, or let's say 10.01 seconds. Okay, so now we're going to demonstrate how it works. First, we take a look at this switch here. We put the switch on actual and then we turn. Okay, I'm turning the knob and nothing is happening. Nothing is happening because the battery clips here have not been attached to the battery. So they are meant to measure the actual battery voltage, but they are not measuring yet because no connection has been done. TJ, can you please help connect to the battery? Okay, there you are. Okay, so this is telling us right now that the voltage on the battery itself is 12.3. Okay, that's the essence of the actual. Now, when you put this on the okay, let's turn the knob again to see what happens. Nothing happens. Okay, on the meter, on the voltage level meter, nothing happens. It remains on 12.3 because that's the voltage on the battery. Can we get an actual testimeter? TJ, let's check with the testimeter. Okay. All right. Okay. You can see 12.4 on this side, 12.49, and then this is also showing 12.4, which is to tell you that that is the value of voltage on the battery. Thank you. Okay, so now we move forward to checking our preset voltage by switching this to preset mode. Preset. Okay, so now you have 0. By the way, by now you should have seen that the meter is multi-purpose. It's serving both the actual voltage and the preset voltage. If I put it back on actual, it goes back to 12.4. So now on preset, I can pick any value I want and turn the knob. As I'm turning the knob, you will see some response on the meter. Okay, that's 10.1 volts. Turn down a bit and it goes down too. Okay, turn it up and it goes up. Okay, so I want to put it on the maximum now. That's the maximum right now. The setting is actually on the maximum. Okay, when you turn it back all the way to the minimum, you have a 0 value. Okay, good. So now that we understand how the knob works, we want to see it in actual operation. Now, if you have a battery of 12 volts, as we have here, you may want to decide that, okay, you want your gen to kick in, because when the battery is fully charged, a 12 volt battery will be in the region of 13.5 or so when it is fully charged. Okay, as it is coming down during use, as it's coming down, the voltage, the actual voltage is also coming down with it. So for most inverters, when that voltage level drops to 10.5, they are no longer ready to keep operating. So a lot of them start turning off or maybe buzzing at that level. So you may want to set your EIBIM to start the gen when the inverter battery has dropped to 11 volts, for instance. Okay, so all you have to do is to set the value to 11 volts. Okay, just slowly turn it and then you get your 11 volts. While the actual is still 12.4, now this setting means that when the battery drops to 11 volts, the gen should start. Okay, because at that level, when the actual and the preset get to the same point, as in when they are at the same level, the IBIM will be triggered and then the gen will start running. Of course, I also need to mention that you need to have this timer set first. You have to set your timer first, because once the trigger sends gen running signal to the gen, we'll be seeing that through this indication here. The indicator will show us when that happens. Now, when that happens, the system will start running the gen, and because it is an automation, you may not want to be involved in the process. So this is the place where you program or set how long you want the gen to run. Okay, and once the timing is complete, the gen will shut down automatically. You can set this in hours or minutes. Okay, that's minutes, that's 0.1 hour, that's second, that's hour. Like this setting, for instance, is 10 hours. Okay, you can change that by pressing these buttons either up or down, and then they will respond to your presses. Okay, but for the purpose of this testing, we'll just set at 30 seconds. Okay, 30 seconds. Okay, this other one here is not relevant to our adjustment. It's not something we need to bother about, but this is the main setting we need to do. 30 seconds. Okay, so that is set and ready. Okay, so right now, I told you earlier when we first put on the IBIM that, you know, some other lights were coming on and we didn't have to bother at that time because our battery had not been connected. Now the battery is connected, the system is ready to work as programmed or as designed. Okay, so now the next thing is to wait for these batteries to drop up to this value of voltage, and that could take forever. You know, since this is a short video, we don't have time to wait for that long. So what we're going to do is to get a device that will help us speed up the process. Now this is called a variable resistor. You can simply call it volume control. Okay, it's a small device that will help us speed up the rundown process of the battery. Okay, we're going to use it to mimic a rundown of the battery so that we see the system triggering the gen run signal. Before I forget, I also need to mention that in case you don't want to use the IBIM for any reason, like maybe you just want to cut it off for the while, you can simply bypass it. Okay, this switch here is meant for bypassing the IBIM so that you don't have to wait until the battery runs down for your gen to start. Okay, that could be useful in situations where you have a lot of guests in the house. Maybe you're having a meeting or an event and you want to put on the ACs and the heavy loads, and you just need to put on the gen immediately. To do that, you can just put this on bypass, and then the gen run signal will be sent to the generator immediately. This is direct signal. It doesn't have to do with your battery conditions or any other thing whatsoever. But because we need the IBIM to work as designed, we're going to put this back on IBIM enable, which is IBIM mode, and then we'll use this, as I said earlier, to mimic quick rundown of the battery. So TJ, can you help us connect that? Let us attach that between this terminal and the battery. TJ, can you set that preset to 6 volts? Let's put it on 6 volts so that we have a much more dramatic view of the action. Okay, good. Okay, good. So the actual voltage is 3.8 right now, based on the setting of this variable. Now, TJ, can you adjust the variable? Let's see its action. turn, let's see. Gently. Okay, turn it all the way up. Okay, good. So now our battery is normal, as in we have normal battery level showing on the indicator now. Now, like I said, we want to mimic battery drop. The preset has been put on 6 volts. Okay. Now, based on our discussion earlier, we said that the moment the actual battery level drops to the same value as what you have on the preset, or a bit lower than the preset, the gen will kick in. The gen starts, signal will come up, and then the ATS will sense that there's need for it, or it's now meant to start the generator. So right now we're using this to represent the ATS receptor on the automatic changeover. Okay, so we're using that to represent the receptor, and then of course we'll see how the system comes alive now. TJ, can you begin to turn down gently? Okay, gently, slowly. Okay, you can see the voltage going down. Our target point is 6 volts. Okay. Keep going. Keep going. We're expecting the gen run signal to come alive when the voltage gets to 6 volts or thereabouts. Don't forget, this is the actual we're monitoring. The preset remains on 6 volts. You only need to set that once and leave it at that setting. The one that keeps going up and down is the actual, because as you are charging, the battery voltage increases. As you are using, the battery voltage drops. Okay. Now we are on 7.8. Keep going. Our target point is 6 volts. We're almost there. Almost. Yeah, about to go live. You can see the green light is coming up. Now the system is alight. Okay, the system has come fully alive. By now your gen has started running, and of course your timer 2 has started counting. Don't forget, our setting is for 30 seconds. We're right now on 20, 21, 22, and then once it is 30, the system tries to stop. Okay. Now, oh, sorry, this one came off. We need to put it back. Okay, TJ, can you do that? Okay, good. So now, while the system is running and the timer is counting, okay, can you do that again? Let the timer start counting. Okay. Now, the timer has started counting because the current battery voltage level is lower than the preset, which is 6.1. Remember, we had a preset on 6 volts, sorry. And then the actual is now on 5.8. So the moment battery starts charging, the voltage starts increasing. Okay, increase the voltage back. Okay, keep going, keep going. And then you can see the trigger went off, the gen start signal also went off. Now what that means is that the voltage level determines when the trigger will come on. Okay, when it is low, the trigger comes on, and immediately the trigger comes on, the gen start running also follows. But when you increase the voltage back into its former status quo by charging the batteries, the green indicator, which is the trigger indicator, goes off. Okay, it goes off, but the green light, the white light remains because the timer is still running. Immediately the timer completes the counting, that's 25, 26. Immediately the timer completes counting, the light goes off, meaning your gen shuts down. You can see even the red light here has gone off too. Okay, so let's take that again. Battery low, system comes on, and then as the batteries are getting charged through the generator or whatever other means, the voltage increases and then the light goes off. The white light remains because the timer is still counting. Immediately the counting is complete, the white light goes off, and likewise your gen run signal on the ATS too is disengaged and the gen stops. Okay, fine. So this is just a demonstration. We have set 6 volts here as the demonstration value, but in ideal sense or in a real situation, your needed setting may be something like 10.8 for your battery. That's for a 12-volt battery, or any value that you find suitable for your inverter. Inverters are sensitive in their own way, so if you discover your inverter starts beeping when your batteries have drained to 11 volts, then your setting will probably be 11.2, yes, or 11.1 for your threshold setting, so that once it is 11.1, before getting to 11 volts, the gen will start running. Okay, so you need to experiment with this to know which value works best with your inverter, or your batteries. Okay, that will be all for today. Please send in your comments, remarks, questions, and any other thing you'd like for us to share. Do not forget to subscribe to this channel, as you'll be one of the first to be informed of any other videos we upload. Thank you and remain blessed. From all of us at Electrokristron Power Systems, we wish you a wonderful year ahead and a wonderful experience in your endeavors. Let there be light.